today we are going to start with some numericals on consistency limits. Okay. Before we start with the numerical, let's first revise what are consistency limits. Okay, there are three limits, primarily liquid limit, plastic limit, and shrinkage limit. What is liquid limit? Liquid limit is that minimum amount of moisture content when the soil will start behaving like a fluid. So it will be that moisture content WL, okay, when the water, it's the minimum, it is this line, okay, it's that water content when the soil will have hardly any shear strength. It will start behaving like a fluid. Okay, so before being in liquid state, the soil is in plastic state. So accordingly, the plastic limit is that moisture content. Again, it is a minimum moisture content for the soil to transit from semi-solid state to plastic state. Is that understood? Similarly, shrinkage limit is the maximum water content for the soil to be in solid state, beyond which it will go in semi-solid state. Now, the corresponding volumes are designated on this particular graph as VL, VP, VD because volume in dry state and volume at shrinkage limit is same. We have already done this, right? Now, let's go to a numerical. Please write down what is displayed here on the screen. I'm reading out the plastic limit of soil. I have written this in abbreviations, okay? You can write down in full form. The plastic limit of soil is 25%. Plasticity index is 8%. When the soil is dried from plastic state, the volume changes 25% of its volume at plastic state. Means what? When you dry the soil from plastic, see when we indicate volume changes, how is that graph shown previously? You have a particular volume at liquid limit. Obviously, the highest volume will be when there is maximum water content. So at liquid limit, you have certain moisture content and certain volume. At plastic limit, it will definitely be lesser. At shrinkage limit, it will be still lesser, rather the least, right? So when you dry the soil from its plastic state, the volume changes 25% of its volume at plastic state. Okay. Similarly, the corresponding volume change from liquid limit to dry state is 34% of its volume at liquid limit. Understood? So determine shrinkage limit and shrinkage ratio. Okay, let's solve this problem. Take a pen and paper and please write down. Don't listen to these videos like stories. Okay, you need to write down and solve. Okay, so this is what the typical graph looks like. So you have volume on the y-axis and you have moisture content on the x-axis. Now let's have a look at your problem. It's already written on your book. What is happening with these when the moisture content is changing? What happens to the volume? Now your problem statement says when you dry it from plastic limit, so obviously when you dry it, how long will you dry till it reach the shrinkage limit? Beyond that, the volume doesn't go down. Can you see this line doesn't go down below the shrinkage limit? So volume is going to be minimum volume is shrinkage limit. So what the statement says from plastic limit to shrinkage limit, when you dry this, the volume changes how much? 25%. Correct? Correct, no? And when the volume dries from WL to WS, the volume changes 34%. Okay, so I will just mark this. You all also mark this on your book. So from liquid limit to shrinkage limit, the volume changes 0.34 times of what was the in liquid limit. And from plastic limit to shrinkage limit, it is 0.25 times of Vp. Now, what is given to you? You are only given the value of Vp. WL is not given to you. You have to find WS, you have to find WL, right? So how do we go about it? Right, so first you finish drawing all these things. Now, once we draw this, I will just minimize the screen now. Okay, we will minimize the screen, so let this be visible. Okay, so now let's start solving. What is given to you? WP, I'll write it little thicker so that it's visible. WP is equal to 25% is given. What else is given? IP is equal to 8. What is IP given as? WL minus WP. So, how much will be WL? WL will be how much? 33%. This is your first answer. Now, volume change from WL to dry state. From this point to this point. How much it is? 0.34 VL. So, in terms of VS, VS can be also written as VD. We usually write it as VD, okay? Because the dry volume is same as the volume at shrinkage limit, right? So, VD, can I write it as VL minus 0.34 times VL? Why? Because in your problem it is mentioned when the volume reduces from moisture content at liquid limit to the moisture content at shrinkage limit, there is a loss of 34%. So is this statement all right? Right? So VD will be VL minus 34% of the VL. Correct? So that is how much? 0.66 VL. I'll write this as my first equation. Okay. Now, similarly, in plastic limit, volume change from plastic limit to dry state is 25%, right? So, the same equation for uh, plastic limit will be VD will be equal to, what will be this? VP minus 0.25 VP, correct? So, that will be 0.75 VP. This is my equation number 2. Correct? Now, let us solve this. These are two equations in three unknowns. Let's make them one equation in two unknowns. So, let's divide 1 divided by 2. What do you get? Please solve. What do you get? So, what I'll get is 0.66 VL divided by 0.75 Vp, this divided by this is equal to Vd upon Vd, that is 1. So this implies that what will be this? So you cross multiply 0.66 VL is equal to 0.75 Vp. Okay. So Vp will be given as, what is Vp will be? 0.66 VL upon 0.75. That is how much? How much is that? Calculate 0.88 VL. Now, what is the meaning of this? This was not given in your problem. This is a new thing that you have realized. Your problem was talking about volume loss from VL to VD. Your problem was talking about volume loss from VP to VS, but this volume loss from here to here was not mentioned. So, how much is that now? So, that means VP is equal to, now we have understood, 12% of volume was being lost from the transition of in the stage of transition from VL to VP. Correct? 1 minus 0.88. So 12% volume was going down. Okay. So now we need to also find out what will be, what is asked in your numerical is shrinkage limit and SR. So we know from here to here so much of transition is there, volume loss. From here to here 25% volume loss is there. But what we need to finally find out is this WS. So how do we go about it? Now you know this is like similar triangles, like, correct? Now let's give this a name. So if I call this point A, if I call this point B, then I'll call this as let's say C, okay, then D, and I'll call this point as E, okay. Now, what do we know? BC, look at this equation, BC upon AC, okay. Can I write it as DE upon AE? Is that okay? Just see. So what I'm trying to do, I'm trying to get this first triangle A, B, C, okay, and the second triangle is D, A, E, okay. So now this A, B, C and A, D, E, what I'm doing, this side divided by AC will be equal to this side divided by A. Is that right? Yeah. So now let's select the right one. So what will be this equal to? Okay. So this will be equal to DE. We have already got the value of WL as how much? 33%. Okay. So DE will be how much? 33 minus 25 will be equal to AE. What is the value of AE? What is the value of A? WL minus volume at liquid limit minus volume at plastic limit. And so I'm asking you, what will be value of this line, length of this line? What will be the length of this line? Will it be 0.12 VL? VL minus VP. VP is 0.88 VL. So this will be how much? 0.12 VL, 12%, correct? So I'm just rewriting now. This is DE upon AE. This will be equal to BC upon AC. Now what will be the value of AC? AC is how much in terms of VL? Huh? So I'm writing this as BC is equal to 33 minus 25 is 8 upon 0.12 VL is into AC. AC is how much? 0.34 VL, correct? Right at the beginning this was given to you, correct? So this means implies BC will be equal to, calculate this, pause the video and calculate. How much do you get? Pause the video. Okay. So you get this as 22.6%. So you got the value of BC. You got the length of BC as 22.6. So what will be the value of shrinkage limit? So shrinkage limit will be WL minus this percentage 22.6. Correct? So that will be equal to 10.4%. Okay, so we've got the shrinkage limit. Shrinkage ratio I won't be able to explain in this video. I'm explaining it in the next video. Please see both the videos in continuity.